Hey, chemistry folks. Today I'm going to be running through the 65's from unit number 1. So if that's what you're looking for, you've come to the right place. All right, on your sheet, what I'll be going through on this is I'll be running through the entire front side. So up top, there are some reminders and some rules, okay, talking about ionic compounds, talking about how to make a formula and things like that. I'm going to skip right over that, and I am going to start right down at number 1, talking about some fill in the blanks. Okay, so hang with me, and this video should not be too long, and I'll teach you all the front, and then the back side is going to be your homework, which will be due in the next class period. All right, let's get started. So, all compounds are blank in charge. Now, what we're looking for there is neutral. We want all of the compounds that we create when we're doing formula writing and formula writing and naming of compounds. Everything we're talking about has zero charge, meaning all of the positives and all of the negatives balance out. Number 2, cations are metal ions, which are positively charged. All of our cations are going to come from the left side of our periodic table. Remember, there is that stair step over on the right-hand side, and that's our dividing line. Anything left is metal, anything to the right of that is not metal. And our metals are going to be positively charged. On the other side, anions are nonmetals, and they're going to be negatively charged. Okay? So this is all review. This is hopefully things you still remember from our previous classes, and now we've just got to combine these pieces, and we're going to start making some formulas. Number 4, define or provide an example of what subscripts are. Subscripts are the tiny little numbers right there. So here's water, H2O. That little 2 is a subscript. Number 5, when are Greek prefixes used? We use prefixes only when you have a covalent compound. Okay, so you can say it as a covalent compound, or you can say that it's two nonmetals. Same thing. Okay, whenever you have a compound that is a nonmetal with another nonmetal, that's covalent. We've got to use Greek prefixes in those situations. Number 6, when shouldn't you use Greek prefixes? Well, when you have an ionic compound, the other type. So we really have two classifications. We have ionic, we have covalent. Almost, I would say the majority of what we give you when we're naming and doing formula writing is ionic. And those are going to be metals with nonmetals or anything with a polyatomic ion. The polyatomic ions are on the back of your periodic table. Okay? So if you have your periodic table with you, that's probably important. I should have said that maybe a little bit ago. But if you have your periodic table, your polyatomic ions are on the back, and we're going to use those if you have an ionic compound. Now, if it's ionic, we do not use the prefixes. Those are also on the back of your periodic table. There's a little table that says like mono and di and tri and tetra and things like that. So those are back there on the back side. You use those as well. The one weird one, which we're pointing out right here, is the exception. There's a polyatomic ion called dichromate. Prefix di makes it seem like it's one of our Greek prefixes for a covalent one, but this is just called dichromate. Number 7, metals lose electrons to become positively charged. So when electrons are lost, what you have left over is a positive charge on that particle. Electrons are negative. So if I take negative things away, I'm left with something positive. On the other side of that, my nonmetals, oh, just kidding. Number 8, an ionic compound. There's a cation and an anion. You can call it a metal and a nonmetal. We could have polyatomic ions. But cations and anions, opposite charges, and they're attracted to each other. That's how ionic compounds are formed. In an ionic compound, the metal is going to be our first element, and our nonmetal is going to be the second element. So the cation is always going to be written first, positive chunk, followed by the negative chunk to make our compound. Number 10, in covalent compounds, elements share the electrons, and the charges are not considered. This is one of the biggest mistakes we see when trying to write formulas. If it's covalent, we don't care what the charges are. We don't need to go to our periodic table and look up both pieces like we do if it's ionic. So covalent, don't worry about charges. The prefixes are going to tell us exactly how many we need, and we don't have to do any math. All right, into my examples. This won't take too long. I'll try to go moderately quick here. What we want to do is we have the name. We want to turn this into a formula. You absolutely are going to need your periodic table. If you don't have one, please go get one right now. Here I go. Lithium. Lithium is element number 3. When I look that up, in that little box, I should see a 1+ charge. I'm going to write that right above. Okay? That's highlighted right here on my smartboard. On your sheet, it says the same thing. Please place the charges above the elements. Nitride. The other part of this is nitride. That IDE ending means that it's an anion. It's a non-metal ion. So if I go and look up nitrogen, which is what nitride is from, I would find that it has a 3- charge. So here's the deal. These lithiums are going to be 1+. Any nitride is going to be 3-. But what did we say way back in the beginning? Any compound we create has to be neutral or 0 in charge. So how do I get a 1+ and a 3- to equal a 0 charge? Well, I have to use little subscripts. So I'm going to start with this. I have lithium. I have nitride. But how many of each of those pieces would I need to get to 0? Because again, I want 0 charge. If this is 3-, well then I better end up with 3+. How do I get 3+? Well, why don't I have 3 lithiums? That'll do the trick. And there's my formula. Okay? So it's math, right? It's you got to look up this first piece, find it, what's its charge? Look up the second piece, what's its charge? Combine those two pieces in a way with a certain quantity of each so that we end up with no charge overall or a neutral charge overall. Number 2, tin-4 bromide. Now, when this Roman numeral shows up, it tells me exactly what the charge is. This is trying to communicate that my tin is 4+. If you go and find it on your periodic table, what you're going to see is that there's options. There's more than one charge in that little box. So if I didn't have that Roman numeral, I couldn't be sure of what that charge is. But this is trying to communicate exactly what it is, and I don't have to think. I can just write 4+ right away. Bromide. Bromide is bromine, but bromide is the ion form of that. If I look that up in my periodic table, I'll find that it is a 1- charge. Same kind of thinking. Now, I want to get to 0. I want to get to neutral. I've got a tin with a 4+ charge. I've got bromides with 1- charges. How can I make this thing neutral overall? Tin has the elemental symbol Sn. Kind of weird. Bromide is Br. And how do I get to 0? Well, I need 4- from 4 bromides and just 1 of the Sn. Okay, really there shouldn't be a gap there. I was leaving space just in case we need to write a little subscript, but we don't. So I'm going to call this SnBr4. Onward and upward. Mercury 2-phosphate. Now, at the bottom here, we're warning you. Ate, ite, and ick. If you see any of these suffixes, the ending of the name, if you see ate or ite or ick, it's probably a polyatomic ion. It's going to be on the back of your periodic table on that list. Okay? So to find phosphate, this is not phosphorus, element number 15. This is its own separate thing, and it's going to come off of our polyatomic ion list. The dead giveaway is that 8 at the end. That's how we know we got to go look for it. So I've got mercury 2-phosphate. Well, the Roman numeral is telling me my mercury is 2+. Cool. I go and find phosphate. On the back of your periodic table, what you should find is this. PO4 with a 3- charge. So I've got 3-. So again, I've got my cation, 2+. I've got my anion, 3-. I need to make something that's 0 in charge or neutral in charge. Well, how do I use 2+ and 3- to get to 0? Well, I'm going to need a subscript for both, right? The common factor between 2 and 3 is 6. So if I could turn my mercuries into a +6, and if I could turn my phosphates into a -6, then I'll have that canceled out, and I'll have a neutral compound like I want. So here I go. Mercury is Hg. kind of like tin, very weird symbol, but is what it is. Phosphate is PO4. And now the question is, well, how many of these cation chunks and how many of these anion chunks do I need? Okay, I need 3 of those mercuries. That would give me a positive 6 on this half. And I need 2 of those phosphates. Because it's a polyatomic ion, I absolutely have to use parentheses around that polyatomic ion. I want 2 of that whole thing, of the whole chunk. So I want to say that 2 of this PO4. I have 2 PO4s, if that makes sense. The parentheses are absolutely necessary. They must be there. Chromium 3 sulfite, ite. That ending again is kind of telling me I've got to go look on the back of my periodic table. This Roman numeral is telling me exactly what my charge is for chromium. It's 3+. When you go and find sulfite, what you'll find is it's SO3 with a 2- charge. Okay, so now here we go again. I've got a 3+ and a 2-. The only way I can get to 0 charge is by reaching a common factor. If I get to +6 and I get to -6, that'll do the trick. So I'm going to end up needing 2 of my chromiums and 3 of my sulfites. But again, because sulfite's a polyatomic ion, I need to use parentheses around that formula in order to show that I want 3 of that whole thing. Okay? Almost done. Hopefully it's making some sense. If not, you can always find myself or Mr. Scheidler in the open lab. Aluminum cyanide. Aluminum, there's no Roman numeral this time. We actually have to go look for it. So I go to my periodic table, I find element number 13, and I see that it's 3+. Cyanide. Now, this one's funky. You see that IDE ending? You might be thinking, oh, well, that just must be an element off the periodic table. It's not. Cyanide is one of our polyatomic ions. Not very nice because that ending is not what we normally would go looking for, but cyanide is the following. It is Cn with a 1- charge. Okay, so I've got a 3+, I've got a 1-. Again, what's the goal? I need it to be neutral. So here I go. I have Al, parentheses, Cn, 3. If I have 3 of those cyanides, that's a 3-. If I have 1 of the aluminums, that's a 3+, 3+, 3-. Life is good. 2 more. Ammonium oxalate. Ammonium. That is our only positive polyatomic ion. It's the very first one on your list. It's 1+. It is NH4. 1+. Oxalate. 8. That's nice. Now we know where it is. That's on the back. I go and look up oxalate, and you should find C2O4 with a 2- charge. So I have a 1+ ammonium and a 2- oxalate. I've got to combine these 2 pieces to get to 0. So I need 2. Oops, I'm sorry, I don't need the 1+. I need 2 of those ammoniums and just 1 of the oxalates. So NH4 parentheses with a 2, little subscript 2 for 2 of them. C2O4 is what I'm looking for. All right, last one, then I'll leave you alone. It's the easiest one. I see a prefix. I see a prefix. This is covalent. And I don't have to do any math. There's no math. I don't want you to look up the charges. It's going to screw you up. Di means 2. Nitrogen is the element. I have 2. Tetra means 4. Fluoride is the element. I need 4. Boom. That's it. Nothing else. These are the easy ones. They're only easy if you catch it, though. If you miss it, then you're going to go down a weird path and start looking at charges, and the math's not going to make any sense because that's negative and that's negative. We don't want you to go there. If you see these prefixes, just write out exactly how many it says, and that's it. So that's all I have for today. Have a good one. We'll catch you later.